Hey you guys, it's Miss Arneson here, and today what I'm going to talk to you about is what do you need to know from the periodic table for solving simple chemical reactions like those of photosynthesis or cellular respiration. So you guys hopefully know quite a bit about the periodic table because they talk to you about it hopefully from elementary school on. But the thing is that the periodic table is so chock full of information that we can keep learning new things about it all the time. So what you need to do to be able to solve these equations is just know the basics. So I'm going to kind of go over some of these basics with you guys really quick, like a review. And I just want you to write down the things that I tell you to write down about this. And at the end, you should be able to basically write down and solve or balance chemical reactions or chemical equations. So that's our goal here. So the first thing I want to do is just talk a little bit about the periodic table itself. This table was invented mostly by a guy named Dmitry Mendeleev. He was Russian and he had a really tough childhood, but his mom thought he was so smart that she basically drove on a horse. See, I don't even know. I don't live in that time period. Took him on a horse all the way across Siberia, which is like a frozen giant area in Russia. And that way he could be left, unlike the rest of his siblings, in a city where he could go to school because she just thought he was so bright. And it turns out she was right. He figured out how to put all these elements together. So people had discovered elements before, and they had also figured out some properties of some elements. And so they knew, like, pretty much that there were some elements. They were the smallest piece of matter that you can find that has its properties. So they're like the basic unit of everything, basically. But there was a lot of stuff missing. They didn't know what order to put these things in. And Dmitry Mendeleev figured it out. And so he basically invented periodic theory and he predicted certain elements would behave certain ways based on the number of electrons and protons that they had. So he was a pretty cool guy and very, very smart and of course super tough because he had that rough childhood. But what he basically did, the reason we're so grateful for him, is that he put these elements in order periodically. And what that means is that there are 7 periods on the periodic table. So if you go and you look at the rows, so here's what I would write down. The rows on the periodic table are called periods. There are 7 periods, and it's really important to have them in these rows because it will help us figure out the number of electrons that are in each of their valence layers. So for example, hydrogen has 1, and then when you go all the way across the periodic table over here, you have 2. If you go down here, you have 3, 4, 5, 6, 7, 8, 9, 10. So he put these in here with their number of protons. That's really how he figured it out because the number of protons defines an element. So write that down. The number of protons defines an element. So if you have 7 protons, that means you are nitrogen. If you have 46, that means you're palladium. You can have different numbers of electrons and different numbers of neutrons. So that's why the proton number is so important, because if you change the number of protons, you actually change the element itself. For example, in the sun with nuclear fusion, you've got a bunch of really hot hydrogen nuclei that are moving around like crazy fast and they whack into each other. And if they whack hard enough, then they become this next element over here with 2 protons. So that's really important information to remember. The atomic number, and if we go over here, we're actually going to draw this periodic table box for oxygen. So go ahead and you can draw that right now somewhere on your page. I would put it maybe like on the very top because we're going to label what each of these parts are. So right now we're learning this part right here, which is called the atomic number. And the atomic number tells you the number of protons. So you want to remember that. Those are 2 important things to know about the periodic table. Okay, the next thing that he realized, Dmitry Mendeleev, is that when a element has 3 valence electron or 2 val one valence electron, like all of these here in the first group. So these down the columns, those are groups. Sorry, my cat's on the table. Get off the table. Those are called groups, and there are 18 groups on the periodic table. And these groups, all of the group behaves together. So you could see if you highlight the alkali metals, the alkaline earth metals, the lanthanoids, the actinoids, it'll tell you basically how do all of those elements that are in that group behave? Like what do they do? And so that's another really important reason that he realized that these are going to behave the same way periodically. So he put them in these nice rows. So the rows are the periods and the columns are the groups. Got to remember that. Okay. Other things like naming the periodic table, that's not really like something Dmitry Mendeleev did. He did like predict some elements, but their names come from all over the place. And I want to kind of look at two different aspects of the name. So let's go back to our little oxygen. We're going to label the O on oxygen as the chemical symbol. The chemical symbol. And the reason we have chemical symbols is so that we can write math equations basically that include elements from the periodic table. So this O for oxygen is if you see an O and it's in a chemical equation, then you know you're dealing with the element oxygen. A couple of things that I want to tell you about chemical symbols. You need to copy them exactly like they are on the periodic table. So here, look at cobalt. Cobalt is CO, and you have to make sure you put a capital C and a little O. If you don't, then if somebody else is looking at your equation and you've written C that's capitalized and O that's capitalized, they're going to think that you're talking about one carbon and one oxygen, not one cobalt. So you have to make sure to do that. The first letter will be capitalized, and the second letter, if there is one, will not be capitalized. For the most part in a biology class, we're going to use what are called the Schnapps elements. Those are C, H, O, N, P, S, S, E. So those are called the nonmetals. And these are the elements of life. So you should write that down. Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, and selenium. If we look at your body, most of your body is going to be made of those elements. So in biology, those are the ones we really talk about a lot. Like if we're talking about DNA or RNA, if we're talking about proteins or carbohydrates, all of those are going to be made of these elements. You do have like iron in your blood. People associate iron with blood, and that's because there is iron in your blood, but it's not really a significant amount. If we weigh your body, then you contain a lot of carbon, and then of course you contain a lot of water, which is hydrogen and oxygen. So those are the elements that we call the elements of life. Okay, let's go back to the name. Okay, this is the chemical name. And so if you're writing out a sentence, for the most part, you want to write out oxygen and save the O or the chemical symbol for when you are writing a chemical equation. Okay, this last number at the bottom, and you can look at some periodic tables and they have a lot more information. Like if we look at tungsten right here, and some of the names don't match the symbols at all, like this is W and it's tungsten. There are names, it's usually like a Latin word for something that makes you, that relates it. But this one, for example, it's showing you all of these, oh dang, it's really hard to move your mouse when, okay, well, I guess we're gonna have to look at vanadium because that's the one it landed on. This right here in the corner is telling you about electrons, and in this class, we don't have to learn about what the electrons are doing in their orbitals very much. So this number down here is gonna tell you, it's called the atomic mass. The atomic mass is the weight of the protons and the neutrons in the most common isotope. But we can remember for now, just for this level, like later on in your junior year, you're going to get more into what the atomic mass means on a bigger scale. But for now, we can just remember that this is the number of protons and the number of neutrons. So if we look at this, it's 15. I would round that up to 16. That would tell us that there are 16 protons and neutrons together. So if we have 8 protons, all we would have to do is subtract 16 minus 8 to find out the number of neutrons. So that is this information right here. When we're balancing chemical reactions, really the most common thing we're going to look at is we're going to look at the O, the chemical symbol, and the name. That's what they're going to give you in these problems, and you might have to look it up on the internet. Or on your periodic table if you have one. Right now you can look it up on the internet, but when you get back to real life class, you'll have to look on the periodic table and know how to use it. So that's why I'm telling you guys these things. So just really key, remember, do not put H capital E for helium. If you're doing helium, you have to have a lowercase e. Otherwise, I don't think there's an element that's just E. But then it would mean something else. Okay, so you don't want to do that. You don't want to confuse your reader and you don't want to confuse yourself. Now, one thing I did want to note here is that when you have one of these things, like one hydrogen, one lithium, one sodium, we would just call that an element. So if you have an atom, it's an element. If you have oxygen, doesn't like to hang out alone, so it usually bonds with another oxygen. So you get something that's called O2. It's a big O and a little 2. That little 2 means that there's two oxygens connected together. And that would mean that that is an elemental molecule because it has more than one atom. If you have water, water is H little 2O, and that's actually going to be considered a compound because it has two different elements in it. So I just want you guys to know that you can put all of these little puzzle pieces basically, or these Legos are the periodic table of elements. The elements, each element atom is one Lego, and you can put them together into a wide variety of things, like, for example, yourself. Okay, guys, that was all for that, and I hope you have a good day. Or keep on doing your lesson, and then when you're done with the lesson, have a good day.